So I'm going to go ahead and get started. Can everybody hear me? I think so. Sounds like it. I'm Bryan. I'm going to be talking about choosing a proxy server. I'm an ATS committer, and I work at Yahoo. So a little bit about me. Like I said, I work at Yahoo. I've worked on a whole bunch of different projects over the years. Currently working on ATS and HP related stuff. Go to IETF for HB2 and TLS working groups. I've worked on traffic server for 7 years now, since 2007, and I was part of the group that open sourced it in 2009. And like I said, I'm an ATS committer. So this is just a brief overview of the presentation. I'm just going to jump into it. So how are you going to use a proxy server? So there's various modes for running a proxy server, and I'm going to talk about that. So one of the main ways to use a proxy server is a reverse proxy server. So this is where you have a browser, and it would connect to the proxy server, and then it would direct it to one of your internal web servers. In this case, proxy server could do caching or not. And so some of the questions that you're going to ask yourself when you set up a reverse proxy server is, do you want to, is your content cacheable or not? So we have different modes where our content is highly cacheable, where you get close to 100% cache hit rate, and then there's other times where it's very low cache hit rate. So sometimes it's just worth just turning off the cache completely, because you take a little bit of overhead having those cache lookups. Not much, but a little bit some. And also for reverse proxies, do you want to have them geographically located next to your customers? So that way, when they're doing requests and three-way handshake, SSL handshake is all close to their customers, so that the round trip time is really reduced. So we have a lot of colos across the world, and this helps out quite a bit. And what also comes into this is connection handling. So in some cases, we'll, so say like in the Philippines, there'll be proxy servers in the Philippines. Users will go ahead and make their three-way handshake. They'll make their SSL handshakes to a local proxy server that's, say, in the Philippines, and then it'll have persistent connections to other countries. So it'll actually make requests over these persistent connections. So a user is not making a three-way handshake from like the Philippines into the United States. So that's something also to consider if you have multiple colos, how you want to do your connection handling. Do you want to do SSL termination? So just recently, Yahoo switched everything over to SSL in Q1, and this was kind of a big thing. So SSL termination, we do a lot of SSL termination on ATS. And do you want to support Speedy? And that's something that we're going to be doing this quarter. And then also, do you want to add business logic into your proxy server? Do you want to write plugins? So we have a lot of plugins in our use cases where you may want to rate limit, you may want to do authentication, you may want to modify the requests or responses. So it's nice to be able to have the ability to do plugins. Another use case is forward proxy, and this is large companies. Even I have a forward proxy at my home. So this is where you hit a proxy server before you go out to the internet. In a forward proxy setup, you actually configure the browser to go to the proxy server. And there's also another use case is intercepting proxy, and this is where you don't configure the browser to go to a proxy server, and it actually just gets routed right through the intercepting proxy, and the proxy is the intermediary before you go out to the internet. So some questions you would ask when you set up a forward or intermediate proxy is, again, are you going to do caching? Is the content that you're surfing, is it cacheable? And do you need to configure do you want to configure your clients to go ahead and use the proxy server or not? And that would be the decision between forward proxy or intermediate intercepting proxy. And also, so when you're doing forward proxy, and you're doing SSL, the proxy server doesn't decrypt or encrypt any of the response. It just actually uses a method called connect, and it just creates a connection out to the the web server or the origin server. So, but if you're wanting to do intercepting or intercepting proxy, then you need to do termination on the proxy server. And this gets a little bit tricky, and there's some security concerns about this, is because you're actually encrypting, decrypting the connection. You have to fake some certs, and there's some things like that. So, and then also the browsers have to have an updated CA bundle. So there's some choices, various choices when looking at proxy servers. There's quite a few choices out there. There's commercial and there's open source. And I'm just going to be covering open source ones today. And I'll be covering these 5: traffic server, Apache HTTP with mod proxy and mod cache, Nginx, Varnish, and Squid. So when you're looking at a proxy server, a lot of proxy servers have, proxy servers have a lot of features and options. And just like buying a car, you need to make sure that it has all the options that you need. And here's a table of various features. It's kind of hard to see on that screen. So I'm just going to kind of go over some of these. So I was talking about reverse forward and transparent proxy before. So the Nginx and Varnish don't do forward or transparent proxy. So if you need to have forward or transparent proxy, you're going to be looking at ATS Squid or Apache HTTP. Most proxy servers support plugins. Squid partially does it. All the proxy servers here, they have cache. The implementations are quite different, and I'll be talking about the architecture in a little bit. Do you need ESI support? Varnish just includes. We use ATS in some use cases heavily with ESI. Squid also supports ESI. ICP, this is for mirroring some of the cache. ATS supports it, and same as Squid. SSL, only proxy server up here that doesn't support SSL is Varnish. And Speedy support, ATS and Nginx support it. It's in the trunk for ATS, and it's going to be coming out in the next release in May. Apache HTTP has what I consider partial support. I've heard the support for it isn't that great in HTTP. I'm sure there's people you can talk to around here. I'll give you more details on that. Squid, they have it on their roadmap to be in 3.5. However, they don't have any bugs open for it, and it doesn't look like there's been any work done. So it's probably going to be a while until Squid actually has support for Speedy. And Varnish, I don't think that's going to happen anytime soon. It doesn't have SSL either. So this is a table that I grabbed for all the different SSL features. So this is a good website to go to for this. It's up to date. Unfortunately, it doesn't cover Squid, but it covers other proxy servers. And ATS, we're working on the OCSP stabling right now, and we expect that to be in 5.0 next month. Yes, do you have any questions? I don't know. I didn't really dig into that. Do you know? So the question was. I would think it would have to support Speedy. So. Okay. So if you're going to be doing forward or transparent proxy, these are the 3 proxy servers that support it. I'm talking about the open source ones. So Apache HTTP, Squid, and Traffic Server. So HTTP 1.1 compliance, so not all proxy servers handle. HTTP 1.1 the same. So some of these issues are around accepting coding. So Nginx has some issues around this because it caches everything keys it on the URL, and it actually doesn't look to see if it's what the accepting coding is. So you can pass back gzip encoded responses when you're not asking for gzip, and I have an example of that. Same thing with Vary. Also, Nginx has issues with age. It doesn't increment age for objects that are in cache. And then also Nginx doesn't handle if none match very well. So in this example, you're doing a request and you're asking for it to be compressed. And it comes back just fine, content encoding gzip. It's the last line there. On the second request, you turn off, you're saying, hey, I don't want gzip. However, because it's uncached gzipped, it's going to come back gzipped. So there's some tweaks that you have to do to Nginx configuration to support this, or you can also run a module, but then you run a penalty of doing compression on the fly in Nginx. So here's some CoAdvisor reports. Tried to do HTTPD with mod proxy, mod cache yesterday, but we were having some issues, so unfortunately those aren't in this slide. I can update it when get those numbers. But in this case, you can see Squid. It's been around for a long time. They support HP 1.1 very well, and then ATS, and then Varnish, and then Nginx. Nginx and Varnish are kind of last. And the violations are kind of important to note. Failures, it could be failure because the test didn't run right, but violations, it definitely did violate the protocol. Squid, again, does the best here at only 6% of violations, and then ATS, and then Nginx and Varnish are in last, again. So before I jump into performance testing, some benchmarks, I'm going to talk about architecture, because architecture has a big influence on performance. And talk about some process models. So there's multi-threading, and this is where you would, classic case of this is Varnish, where it just has tons of threads, a thread per request. Event-based process model. This is much like what Nginx does. It has an event loop, and I'll talk about what event loops are in a minute. Process is kind of the old school HPD, where you spin up a whole bunch of processes for each request, or actually for each connection. And Fibers, worked on a project that wasn't too successful. It used Fibers, and it does cooperative multitasking, does get and set context. You have to basically set up your own scheduler and everything for figuring out what task you want to run. So, classic multi-threading. You have a single CPU, you can only run one thread at a time, but you'll have the kernel, it'll be picking and choosing what thread to run, and it tries to interleave it and makes everything look like it's happening at the same time. Dual CPU, you can run 2 threads at the same time, and again, the kernel decides which threads to run. So in threading, the pros are is it's easy to share memory. This is good for like caching, for like say DNS caching or object caching. It's really easy to share things. You have to, of course, use locking. And it does lightweight context switching. So switching between threads is pretty lightweight. Processes is heavier weight when switching between processes. Cons, it's easy to share memory accidentally. So this happens, this is kind of probably one of the big gotchas, is you can have a thread modify another thread's objects in memory, and it can be difficult to track down. And this has probably been where I've spent a lot of time on multi-threading is because a thread can modify another thread's object or data structures, you might not see the problems with that until later, and you might not know exactly how that happened, and it's very difficult to track down. Locking, deadlocks, race conditions, starvation. Out of these 3, I'd say race conditions I've run into being most problematic. Again, it's kind of hard to figure out what's going on there. Event processing is basically you have a whole bunch of events, scheduled events, network events, disk events. They get queued up, and you have an event loop that goes around, grabs the events, works on the event, and then continues around through the loop, grabbing more events. Some issues with event processing. It doesn't work well with blocking system calls, so or blocking APIs. So if you're doing open just to the file system, that's a blocking system call. Also, if you're doing any locking, you could be blocking. When you block that event loop, you're not working on any other events at that time. And also, with event processing, it doesn't scale well on SMP multiple cores on its own, so you have to use either multi-threading or multiple processes to actually use all of your cores. And it's just a table that talks about which proxy servers use which type of process model. ATS uses multi-threading, and it also uses events, Nginx events, and then multiple processes. Squid, same thing as Nginx. Varnish, it uses a boatload of threads, one for every request. So when you're benchmarking, you have a lot of connections. You'll see a lot of threads spinning up, and you'll see a lot of context switching. It does some stuff with events, but it's mainly thread-based. Apache HTTP, that's kind of nice. You can specify, you can pick which type of process model you want through the NPM. And actually, in my benchmarks, the default was events for the source code, and I believe that would perform the best, so that's what I was using in my benchmarks. Kind of flying through the slides. Cache architecture. So I'm going to go through and talk a little bit about the cache architecture. So there's mainly two types that these proxy servers that I'm talking about use. One is file system. This is basically where you have a hierarchy of directories. And most of the time you can specify how many levels of directories and how many directories at each level. But basically, at the end, there's a file, and that has the cache object. And then there's database-like, where it uses either the raw disk or does direct I/O on a file. And it basically manages how the objects are placed inside this file. It manages indexing and everything. And then also with caching, you can have in-memory indexes. So Squid and ATS, they both have, you can have full in-memory indexes of all the objects on the disk. And something that's really important about this is how many bytes per object does this index take up. So Squid takes like 70 to 100 bytes per object. ATS takes 10 bytes per object. So ATS takes considerably less memory per object, and it's very helpful if you have very, very large caches. And then you also want to minimize your disk seeks and system calls for cache. And there's some tricks that even the file system-based caches do. So they'll go ahead and they'll cache open files and things like that, and they'll cache metadata so you don't have to do open quite as often. And this is a table that just describes which proxy servers use what type of caching architecture. So ATS uses raw disk or direct I/O to a file. It also has the ability to have a RAM cache turned off or on. Nice thing about having a RAM cache is you're going to grab the object from memory. You're not going to have to go out to the operating system or do any system calls to grab the object from, and then you're able to just write it down to the socket. ATS, like I was mentioning before, has an in-memory index, and it's a persistent cache. So Nginx, file system, and it's persistent cache. And like I was mentioning before, it has the ability to do caching open files. However, it's not all the objects in cache, so some of the times you're going to have to actually go and do opens on files. Nginx is an event loop, and doing open is blocking system call, so there's some issues there. Squid, you can set it up. It has two different types of storage systems for their cache. It has file system based, which is just a hierarchy of file or hierarchy of directories and then a file, or you can use what's called the rock store. There's issues with using rock store. It's kind of, so rock store, there's some advantages and disadvantages with rock store. Rock store allows you to share the cache across the processes, but so there's some size limitations. The maximum size of the objects in the rock store is like 32K, so that's kind of limiting. With Squid, you can specify a RAM cache or not. It has an in-memory index, except it's kind of, it's heavier than, say, ATS on the in-memory index, but by 10x. And it has a persistent cache. Varnish, it's just an mmap, so it's not really that sophisticated. It's not persistent by default. They do have an experimental cache that's persistent, but experimental, and I've heard it doesn't perform very well. And because it's an mmap, you basically have an in-memory index of all the objects. So, so you're not going to really be doing very large caches with Varnish, just because it has to be an mmap and has to be in memory. Apache HTTP, much like Nginx, file system based, cache hierarchy of directories and files, and it's persistent. So I did some performance testing, did some benchmarks, and also going to go over the configurations that I did with each one of the proxy servers before I actually did the benchmarks. So ATS configuration, it was pretty straightforward. It was 3 lines that I had to add into the configuration files. First one is just map all URLs to your origin server, and that's in the remap config file. In records.config, I had to change the port. The default port is 8080, so I had to change it to 80, pretty basic. And I had to turn the number of accept threads on this box. It was a 24-core box. So I turned the number of accept threads to 3. It automatically scales on the number of threads based. It looks at the core, and it figures out how many worker threads it needs to actually create based upon the number of cores around the box. So that's kind of nice. It scales well doing that. We probably need to put something in where it auto scales the accept threads if it sees that you have tons of cores. Nginx, this kind of gets into the HB 1.1 compliance. So a lot of this is trying to get around or trying to help Nginx do the accept encoding gzip. And then also the last section is so you can do purges in the cache. And they have a third-party module that'll do the purging. And in this one, I had 24 workers. Squid was using the rock store for benchmarks, and then also did memory or RAM cache. Varnish, pretty simple, 2 lines. However, it's really not this simple, because when you actually execute the server, it gets very complicated. So these were the four trials that I did, and the last line is actually the one that seemed to perform the best. And you have to go through and read the documentation on this about, what your thread pool size is going to be, what's your minimum thread pool, and then stuff like, thread pool add delay, like the thread creation and things like this, and session linger. I don't fully understand it, even after reading the documentation, but I have a pretty rough idea of what it needed to get good performance. Yes?
You said only does memory, but it also does disk as well. So you didn't try the disk way?
No, I did not try the disk in benchmarks, because I knew that would even perform worse.
It actually performed pretty well on our side.
It did? Okay. Because I've heard from other people when it gets very large caches that it's, yeah, it does in size.
We did like 8 gig or 10 gig.
Okay, yeah, I'm thinking like terabytes, yeah. Apache HBD configuration, pretty basic. I had one of the Apache committers also help me to try to tweak the number of, I guess it'd be processes and threads and stuff, and we actually, in the benchmarks, it made the benchmarks come out even worse than the defaults. So I just kept with the default numbers. So in the first benchmark, this is just a standard keep alive benchmark. 1,000 clients, 8K response, 100% cache hit rate, and then I limited to 100,000 RPS. So, and this box had a 10 gig NIC, and I was pushing about 8 gigabit doing these benchmarks. So in this, so this is the results of the benchmark. So this is kind of the graph in the lower left is the throughput, how many requests per second. And they're all going to hit around 100,000 because it was rate limited to 100,000. And the upper right talks about basically how efficient the proxy servers are. Is how many requests per percentage of CPU. And this is the lower right is basically the latency. So a couple things to note. Squid used more CPU than any other proxy server. And the proxy servers had issues with the 95th percentile. It was HBD, Squid, and then Nginx. And actually, when I tried to tweak the number of processes and stuff for HBD, it actually made this was the number that I was trying to get lower, was the 95th percentile number for HBD. And actually, it made it worse. It went up to like 40 milliseconds. So that's why I just kept this number. Benchmark 2, this is turning off keep alive, basically. So this is how fast can the proxy server accept a connection, process a connection, and move on to the next connection, or request. Oh, connection, actually. And this is the results of this benchmark. So same thing, lower left is the throughput. ATS slightly beat Varnish. In the upper right is basically how efficient. Nginx was very efficient, but it had tremendous latency issues, and the throughput was low. So I don't know if I would actually call that success. ATS did better in efficiency a lot better than, say, Squid. Squid was, again, very bad on CPU usage. And then Varnish and HBD. On the latencies, the two that did the best were ATS and HBD. It was 1 millisecond for the mean, and for the 95th percentile, HB did the best at 2 milliseconds, and ATS was at 3 milliseconds. I mean, all really, really good. So generally in benchmarks, we like to, so I'll probably highlight that a little bit. In benchmarks, we like to look at the medians and then also the 95th percentiles, kind of see exactly what your tail end looks like. And that's why I was using these numbers, the median and the 95th percentile. Kind of gives you an idea of what your distribution looks like in your response times. Taking like the median or something like that, taking the mean sometimes can be really not show the full picture of what's going on. So I'm just going to kind of go through some of the pros and cons of the different proxy servers. So ATS, the pros, it scales well and scales well automatically. Little configuration, like I showed, it's just 3 lines. And I believe it has the best cache implementation. So I didn't really go over this in a lot of detail, but ATS, it uses what's called a cyclone cache. That's what it's called in ATS. It's very much like a log-based file system. So it merges the writes together and sprays those all out at once. So you're not doing a lot of seeking for all your writes. And also it's, like I said, it's very, very efficient on the in-memory index. Yes?
What about larger size files, like over 100K size, like HTTP or?
The only one that I would see that would have an issue would be Squid with the rock store, but ATS and ATS is just fine with large files. I mean, even like gigabytes size objects, and the other ones just use the file system, so it shouldn't be an issue. Cons, We have a lot of configuration files and too many configuration options in the file. So sometimes it can be a little bit overwhelming when someone new comes into it. Even though you have to just modify 3 lines, it could kind of be overwhelming when you see all of that hit you right at once. Nginx, the pros, lots of plugins. You got fast CGI support. Cons, HTTP 1.1 compliance. It doesn't do very well. And there's latency issues around accepting new connections in the benchmarks that I did. Also, if you want to add in new plugins, this is kind of a pretty big killer for us, being a large company, is anytime that you want to go ahead and, each group wants to have a new plugin or something, you have to recompile the whole server. So that's a pretty big issue. Squid has the best HTTP 1.1 compliance. However, cons are is that the in-memory index isn't very efficient. It uses a lot of CPU for what it does. And it had the worst median latencies for the keep alive benchmarks. Varnish. Big pro for Varnish is the VCL. It's the configuration language. One thing that's nice about this, you can do a lot of manipulation of requests and responses without actually having to write modules, without having to do C code. So a lot of people like this. We're talking about doing something like that in ATS, but that's, we have just kind of an experimental implementation of that right now. Cons, you have a thread per connect. Actually, it's a thread per request. So you have tons of threads in the system. Mmap for cache. For some, this can be a con because you don't have persistent cache. Also, it's just you can't have very large caches. And it doesn't have SSL or Speedy support. So if you want to implement SSL or Speedy, you're going to have to put another proxy layer in front of Varnish to go ahead and handle all that. Yes. Yeah, that's why I said thread per request. Yeah, I know, yes. Thread per non-idle connection. Apache HPD Pro also has lots of plugins or modules. It's most used, it's very, very common out there. It had best 95th percentile latencies for non-keep lives. I mean, it was like a millisecond better than ATS. And you're talking 2 to 3 milliseconds. Cons, the speedy support isn't that great from what I've heard. So why did Yahoo pick ATS and why might you want to pick ATS? Is it scales well, it's very efficient on CPU, does auto configuration for you. The cache scales very well. There's people who run large caches and are doing 20 to 40 gigabits per box. So it scales very well, very, very well. Efficient memory index, so if you're having very large caches, that helps. And it does things to minimize seeks. Another, I didn't really cover this too much, but another big reason to have an in-memory index is you know what all your objects are in your cache by just looking in the in-memory index. You don't have to go out to disk and do disk seeks or look in directories or whatever to go ahead and find out that you don't have the object in cache. So depending on your situation, having an in-memory index can be very helpful. Another good thing about ATS is it's part of Apache community. It's easy to make contributions. Everything, mailing lists are all open and everything. So that's a big advantage. And then also plugin support has the ability to write plugins, much like a lot of the other proxy servers. And for us, it was easy because we were running a Yahoo version of Traffic Server. It was easy for us to port all of our plugins over to ATS with minimal effort. Here's some references of the different proxy servers. And any questions? kind of flew through the slides. Yes?
How was the CPU when you ran the test on ATS? Because Varnish is like 0.1 CPU even on high load.
Let's see. So you want to look at that? This is 100,000?
Yeah.
So ATS actually did the best on CPU usage. Over. This is how many requests it did per percentage of CPU. So basically, bigger is the better. Bigger's better. And if you look at, where is it? The results for this benchmark, Nginx did the best here. I got most, but it wasn't doing very much. If you look down at what the throughput was, it was pretty low compared to, say, ATS. Well, it was lower than ATS and Varnish, but then also your latencies are really high. So yeah. So if you take Nginx out of there, again, ATS did the best. Basically, it was the most efficient on CPU usage. Yes. Okay, so your question was, did you look at other proxy servers for forward proxying because you mainly just focused on caching? Yeah, in this case, I didn't do any benchmarks on just pure proxy server. I didn't want to have just like slides of benchmarks because there's so many different variants you could do. Also, one thing is once you start throwing in, take caching out of the equation, then you start, how does the origin server perform and things like that. But yeah, it's probably good to also look at that. Depends on what your use case is. At Yahoo, we do have one proxy. We have a proxy setup that's basically more for static content, very high cache hit rate, and then we have another proxy setup that basically is low cache hit rate, does tons of proxying. In the real world, ATS performs pretty well. But it would be good to see exactly how that performs against other proxy servers. Yeah, so unfortunately, I don't have any benchmarks here to show you that. Yes?
Did you do any benchmarking of evictions, so where the cache fills up and you've got to bring in new documents into the cache versus what's going on in the cache while it's underload, so encouraging the cache while it's underload as well?
Yeah, so the question was, did you do any benchmarks on large caches where you're filling up the cache? In this case, no, I didn't. But looking at the architectures, you can kind of figure out what's going to happen with the file system-based cache once you start getting into very large caches. We do have some very large caches like Flickr that runs Squid, and they have issues with in-memory indexes and performance. They're looking at switching over to ATS. Yeah. So the answer from Jan was basically that that Varnish starts falling over on the persistent caches when things start filling up. It just wraps around. It does have to update the in-memory index, but all that's pretty lightweight compared to going out to disk and having to delete objects and stuff. So like Squid, it's an LRU. It has to go through and has to remove objects off disk and update directories. And
you can set a TTL in ATS to dispense with things that once it passes a certain lifetime, you don't keep them in the cache anymore?
well, most of the time you have that on your responses. You have max age headers and things like that, and then those will just expire based upon the object itself. You can actually do some overrides, cache overrides and cache config to go ahead and set TTLs on objects. But most of the time, hopefully you have good origin servers that actually send correct headers and that they actually are so you don't have to fix it up in the proxy server. Any other? Yes. Having a hard time here. It's going to, so the question was, are you going to bring ESI into the core, or is it going to remain a plugin? My thoughts, I'm not the only one that decides this. My thoughts is that it would remain a plugin. I don't see it being pulled into the core. What are your thoughts on that? Are we going to bring ESI into the core or keep it as a plugin? ESI. I would think keep it as a plugin. I don't see a reason to bring it into the core.
In general, we try to keep things as plugins just because dealing with sort of modularity is much easier with so to get community participation is much easier with smaller pieces.
It's something that not everybody uses too. It's not a feature that, at least in our use case, there's some groups that use it, but for the whole, not everybody uses ESI. Any other questions? So the question was, did I test with any other response sizes than 8K? I did some 16K, but I mean, at that point I was, maxing out the NIC, so I didn't really do that. I wanted to keep it kind of under what the NIC was when I was doing 100,000 RPS. So that was the kind of the what I wanted to do. But yeah, I mean, you could push a lot more bits if you wanted to go ahead and do larger objects. Any other questions? Okay, well, I think that's it then. Thank you.